Alright guys, good morning. Today we're going to be covering 1.2, angles and conversions. Our learning target today is I can convert degrees to degrees, minutes, and seconds. Then also we'll be doing a secondary learning target, which would be I can find the measure of an angle between hands on a clock. Between hands on a clock. So those will be our two learning targets that we cover today. So keep that in mind. All right, so getting started, we're just going to review through our angle types. So we have 4 different angle types, and then we have some examples for them, and then the restrictions. Now the restrictions are extremely important for us. We need to know what we can go to with these angles. So for our first type, we have an acute angle, and an acute angle can be between 0 degrees and 90 degrees. So again, it can't be below 0 degrees because that wouldn't be an angle anymore. And if it's at 90 degrees, it wouldn't be an acute angle anymore. It would then be a right angle. So restrictions for acute is between 0 and 90. For a right angle, it is exactly 90 degrees. For an obtuse angle, the smallest that we can get is right above 90. It can't be equal to 90, of course, because that's a right angle. And it can go all the way up to 180. So it'll be between 90 and 180. Then lastly, the straight angle. Straight angle just makes a straight line. Straight angle is equal to 180 degrees exactly. So those are our angle types. Those are some examples, and then the restrictions that take place. And the restrictions are the important part here because that will kind of dictate what exactly we're dealing with when they give us restrictions on angles. So let's go ahead and move forward. Next up, we're going to work on conversions of degrees. So we have parts of degrees here. Now, we know for a fact that 1 degree will equal 60 minutes. And this little apostrophe here, that stands for minutes. So anytime that you see just one single apostrophe, that means minutes. So 60 minutes is 1 degree. Meanwhile, in 1 minute, we have 60 seconds. So 60 seconds equals 1 minute. And again, the symbol right here is for seconds. So if we do some dimensional analysis, well, 60 times 60 will equal 3,600. So 1 degree is equal to 3,600 seconds. So the important part here is this conversion table. So we should be able to convert between minutes, degrees, and seconds. And we'll be doing that in just a second here with some practice. So again, if I have 1 degree, it's equal to 60 seconds. If I have, if I have 0.4 of a degree, it's equal to 24 seconds. So just as an example there. So there's going to be quite a few different things that we see here as we go through. So let's go ahead and try out our first example. Our first example, we have 87.5 degrees. So I start off by leaving this 87 here, and I do that because I have a decimal point. So I'm left with 87 degrees. And then if I want to convert this decimal, to minutes, I'm going to take that decimal, 0.5, and I'm going to multiply it by that conversion rate. Well, the conversion rate was 60. So I multiply 0.5 times 60. And if you think about it, if 1 degree is equal to 60 minutes, then half a degree should be equal to 30 minutes. So 0.5 times 60, of course, is 30. And that's our answer, 87 degrees and 30 minutes. Now, if I want to convert this all the way down to degrees, minutes, and seconds, there's another part that I have to do. But this is an acceptable answer as it is. It depends on what the question's actually asking. So if it says convert all the way down, then of course I need seconds still. So it gets seconds. As I can see, I don't have a decimal place anymore in my minutes. So I can't just multiply by 60. What I need to do is I need to subtract 1 minute from the 30. So I now have 87 degrees, 29 minutes. If I subtract 1 minute from the 30, I'm left with 29 minutes. But that 1 minute also gives me 60 seconds now. So again, 60 seconds is equal to the 1 minute. And that's where the 60 came from, the 1 minute. And this is also an acceptable answer. 87 degrees. Sorry, I had that up here. So I had 87 degrees and 30 minutes, or 87 degrees, 29 minutes, and 60 seconds. Both of these are acceptable answers for us. Next up, there we go. Next up, we have 60.4 degrees. So 60.4 degrees. We're going to do the same type of thing here. So again, I start off with my degrees, so I have 60 degrees. And then this time, we have 0.4. So I'm going to do 0.4 times 60 minutes. That way I can convert the decimal to minutes. So 0.4 times 60 will give us 24. That's equal to 24, so I now have 24 minutes. This is an acceptable answer. If I want to convert it to minutes, degrees, and seconds, I'm going to do the exact same thing that we did on the last one. I subtract 1 minute, which will leave me with 60 degrees, 23 minutes now, and that subtraction will give me that extra 60 seconds. So that 1 minute turns to 60 seconds. And again, both of these answers are correct. Either one would be accepted. All right, next up, 90 degrees. There it is, 90 degrees. So if I have 90 degrees and I need to convert it to degrees, minutes, and seconds, this time we notice that we don't have a decimal. So if I don't have a decimal, I'm going to do what we were doing to our minutes. I'm going to go ahead and subtract 1 degree. When I subtract 1 degree, I now have 89 degrees. And that 1 degree will give me 60 minutes. Now, if I want to go ahead and reduce that to degrees, minutes, and seconds, I subtract 1 more minute, which will leave me with 89 degrees, 59 minutes, and 60 seconds. So again, same type of thing. If they don't give me a decimal, I just subtract. If they give me a decimal, I multiply. Again, if I had a decimal over here with the 24, if it was like 24.5, I'd multiply my decimal again by 60. So we're multiplying the decimals by 60. That's the important part. Our last one that we have is 180 degrees. So it's kind of hard to see right here. I'll bring it out over here, 180 degrees. Go ahead and pause the video if you'd like. Try this one on your own, and then we'll get right back into it. All right, so this one is very similar to the 90 degrees one. Again, I just subtract 1 degree, which will give me 179 degrees in 60 minutes. If I want it in seconds as well, I subtract 1 minute, and that'll give me 179 degrees, 59 minutes, and 60 seconds. Again, this is the correct answer if we're converting it all the way down. This could be the correct answer if they only give you 2 spots. It depends on if they give you 3 blank spots or 2 blank spots, depending on how long your answer will be. So that is how we convert from degrees to degrees, minutes, and seconds. So again, we should be able to do that. Now, let's go ahead and try one of these in a geometry problem. Sorry, let me just click through here real quick. My slides have been acting up some. One more time. There we go. All right, so our first problem. Given ABC is a right angle, and angle ABD is 67 degrees, 21 minutes, and 37 seconds, find the measure of angle DBC. So first off, we know ABC is a right angle, so I can draw that in. There's my right angle right there. Next we also know that angle ABD is, so I have angle ABD, this red angle here. This red angle is equal to 67 degrees, 21 minutes, and 37 seconds. We want to find this missing angle right down here. So we want to find the measure of angle DBC. So, to do that, we can go ahead and use something that we learned yesterday. We learned about the segment addition postulate yesterday. The segment addition postulate also works with angles. So, I know that we have 90 degrees here, so I can say the measure of angle DBC plus 67 degrees, 21 minutes, and 37 seconds. So this purple angle plus this red angle is equal to the whole thing. It's equal to the whole thing. Well, the whole thing, ABC, is 90 degrees. So it's equal to 90 degrees. Now from here, I just need to solve for DBC. So to do that, I subtract 67 degrees, 21 minutes, and 37 seconds from both sides. Now, I'm going to go ahead and bring that out a little bit. So I have 90 degrees. Let's go ahead and convert this 90 degrees. So 90 degrees is the same as we just learned on the previous slide. It's the same as 89 degrees, 59 minutes, and 60 seconds. And we're subtracting 67 degrees, 21 minutes, and 37 seconds. And when we do that, we'll get our final answer, which is the measure of angle DBC. So 60 seconds minus 37 seconds will give me 23 seconds. 59 minutes minus 21 minutes will give me 38 minutes. And then 89 degrees minus 67 degrees will give me 22 degrees. So the measure of this purple angle, our final answer, is 22 degrees, 38 minutes, and 23 seconds. Now, if I want to convert this back just to degrees, say they didn't want me to have it in degrees, minutes, and seconds, they wanted it in degrees. Well, here's how we do that. So what I would do is I would take my last number, my seconds, and I'd take that number, and to get to our seconds, what we were doing is, if you remember on the last slide, we were just multiplying by 60. So to go backwards, I need to do the opposite of that, the inverse operation, which would be divide. So I have 22 degrees, 38 minutes, and 23 seconds here. I'm going to go ahead and take my last term, that 23, and I'm going to take this whole thing, and I'm going to divide it by 60. So when I do that, that leaves me with 23 divided by 60. That leaves me with 0.3833 repeating. So I now have 22 degrees, and then I'm going to take that decimal place, that 0.38333 repeating, and I'm just going to add it onto the 38. So I now have 22 degrees and 38.383 repeating minutes. Now from here, I'm going to go ahead and I'm going to add this chunk. I'm going to do the same exact thing. I'm going to take this chunk, I'm going to divide it by 60, and then I'm going to add it to the 22. So 38.3833 repeating divided by 60 will give us 0.63972 repeating. So again, that's 22.63972 repeating degrees. So I just took this number, divided them, and then I added it onto the end. I added that decimal place onto the end. So these two numbers are equivalent. These two are the same. So 22 degrees, 38 minutes, and 23 seconds is the same as 22.63972 repeating. All right. Let's go ahead and try out a practice problem on restrictions. So this is conversions. This is one of our main learning targets. So we finished that for today. And this will keep coming back up. So make sure that you guys are comfortable with conversions. And if you have questions, come ask me. All right. Next up, I have this angle here, angle B. And I know angle B is acute. So we know angle B is acute. I'm just erasing that to make sure that there's no confusion on this one. Now, they want to know the restrictions for angle B and the restrictions for X. So I know angle B is an acute angle. So I know angle B must be between 0 degrees and 90 degrees. Because again, those are the restrictions because it's acute. If it wasn't acute, then we'd have different restrictions, of course. So that answers the first question. Now, I notice the variable X is within our angle itself. So I know X needs to follow these same guidelines. It has to be between 0 and 90. So I'm going to take this whole chunk, what angle B is, 2x plus 14, 2x plus 14, and I'm going to have the same restrictions on it. It must be between 0 and 90. And again, angle B is between 0 and 90 as well. So from here, we go ahead and we solve. I start by subtracting 14 from all three sides. This will give me negative 14 is less than 2x, which is less than 76. From here, we divide both sides by 2, or sorry, all three sides by 2, which will give me -7 is less than x, which is less than 38. And those are our answers. So again, angle B must be between 0 and 90 because it's acute. Meanwhile, x, the variable, for this to remain an acute angle, x has to be between -7 or greater than -7, but less than 38. So those are our restrictions. All right, the last thing that we're covering today is going to be the measure between the hands formed by a clock. So our first example is 4 o'clock. Now, in a clock, we know that there's 12 numbers that surround the clock's edge. It starts at 12, goes all the way around, back to 12, in a clockwise rotation. So, I know that there's 12 numbers that are placed around the clock to determine the hours, and I also know that there's 360 degrees total in a full rotation of a circle. So, if that's the case, we have 360 degrees, the whole amount, divided by the 12 hours that surround the clock, which gives us 30 degrees for every 1 hour. So what that means is that between 12 and 1, this angle is 30 degrees. Between 1 and 2 is also 30 degrees, 2 and 3 and 4. So therefore, the measure of this angle between the hands on the clock, the measure of that angle is just 4 times 30, because again, we have 4 30s here, which would give us 120 degrees. Now, sometimes it's not perfectly on the hour hand, and we need to calculate how much that's traveled past the hour hand. So that's similar to this question. At 5:15, what is that angle that's formed? Well, you get started on this one. We were going to go ahead and break it up once again, so I know that every 30 degrees, 1 hour's passed. So I can go ahead and try and split this up a little bit. So I have 30 degrees between 3 and 4, 30 degrees between 4 and 5, and then I need to find this little tiny angle here between 5 and the hour hand. So this is what we're looking for. So to do this, I'm going to go ahead and take where the minute hand is at on the clock. It's at the 3. And I know that there's 12 total here. There's 12 total hours. So I divide that by 12. Now, if you're more comfortable, you can take the minutes and be like, okay, there's 15 minutes. And I know that there's 60 minutes all the way around a clock, right? So 60 minutes in 1 hour. So I can do 15 divided by 60, or I can do 3 divided by 12. Regardless, we'll get 1/4, right? This fraction is 1/4. So that means that the minute hand has traveled 1/4 of the way around the entire clock. That also means that the hour hand has moved 1/4 of the way between 5 and 6. So it's 1/4 of the way there. If that's the case, and each hour is 30 minutes, then that means that we've traveled 1/4 of 30 degrees here. 1/4 of 30 degrees. Well, 1/4 times 30 is equal to 7.5. So therefore, we can find our final angle here. Our final angle is 30 plus 30 plus 7.5. Or, as our final answer, it's 67.5 degrees. And again, here it is. Take that 3. I always put it over 12 if I'm using where it's at based upon the numbers. If I'm using the minutes, I put it over 60. So this will always be over 12 or over 60, depending on which route you want to take. I always multiply by 30 because that's how much we've gone around. The only part that you need to be careful is if it's going the other way and you're finding out how much more of an angle we need to cover. So we'll practice these down the road, and we'll get more practice in with them as well. All right, other than that, we've covered these learning targets, so I can convert degrees to degrees, minutes, and seconds, and I can find the angle formed by the hands on a clock. So those are the 2 learning targets that you guys absolutely need to know. The restrictions will also benefit you guys. Of course, if you have any questions, email me, let me know, put them in the comments. Thank you for stopping in and watching. I hope that you guys have a great day.